solve the system algebraically. So using substitution, I get to set these two equal to one another because it's y equals and y equals. And now I'm going to move everything to the left or the right. There's no wrong answer, but there's generally an easier method. I'm going to move everything to the right. So there's nothing left on the left-hand side. And now I'm going to combine like terms. And now I can solve using possibly factoring. I haven't checked yet. Is it factorable? Remember, if factoring doesn't work, you're always able to use the quadratic formula. So is there two numbers that multiply to give you negative 20 that combine to give you a positive 1? And that would be positive 5 and negative 4. So x plus 5 and x minus 4, because the leading coefficient is different than 1, I have to divide by that number. Now, this is not asking you to write it in factored form, so I can stop right now, and the question is solve the system. One answer is x equals negative 1. One answer is x equals 4/5. So most people stop here, and they only receive half credit. Notice this problem has an x and y variables. So how do I get the remaining answers? Okay, how do I achieve the y answer? I look up here and I choose one equation that looks easier. I'm going to choose the first equation, and I substitute in this case a negative 1. A negative 1 plus 7. Two negatives make a positive, and 1 plus 7 is 8. So one ordered pair is negative 1, 8. Now 4/5. I'm going to use the same equation, and I'll use a calculator to do the work. So negative 4/5 plus 7. Grab your calculator, negative 4/5. Again, negative 4/5 plus 7. Turn it back into a fraction, although a decimal would not be wrong. And 31/5. So this is 4/5 and 31/5. Equivalent decimal answers would be acceptable.